So here, the first question is basically if you have been given f dash x is 8x upon a root of 2x square plus 1, given that f of 0 is 5, find f of x. So since you have been given derivative and if you wish to obtain the function back, you'll integrate the expression 8x over root of 2x squared plus 1. Now, the second question comes is like, how do we integrate this? So you're going to take, let's say, make a substitution, u as 2x squared plus 1. Now, when you make the substitution, you need to replace this dx in terms of du. So du by dx is going to be 4x. So if you make dx the subject, it is du upon 4x. So that you plug out here. So as a result of that, you'll get f of x equals to integral of 8x upon root u times du upon 4x. So this get cancelled and you get the outside answer is 2. So 2 over du upon root u, which is 2 u to the power negative half du, because 1 upon root u is u to the power negative half. Now if I integrate this using the formula, if you have u raised to n du, it will be u raised to n plus 1 upon n plus 1 and plus c. So this is going to become 2 u raised to half over half plus c, which is basically this half goes up and become 4, and u raised to half is root. So 4 root u plus c. And now since you took u as 2x squared plus 1, so my f of x is 2 or 4 root 2x squared plus 1 plus c. Now you take x as 0 and y as 5. So 5 equals to 4 times root 1 plus c. So that's c equals to 1 basically. And you get the final expression for f of x as 4 root 2x squared plus 1 and plus 1. So this is the expression that we needed. So here f dash x is, there's a second question, which is like from derivative you wish to obtain the original function. So if I integrate the f of x, I get the function which is integration of 3 root x. So integral of basically 3 can be taken outside and x to the power half. Now this is 3 x to the power half, integral is x to the power 3 by 2 divided by 3 by 2 plus c, that's f of x. So if you simplify this, 2 goes up, so it'll become 2 and this 3 and 3 get cancelled. So 2x to the power 3 by 2 plus c, that's your f of x equals to. Now if I plug in x as 1 and y as 3, I get 3 equals to 2 1 to the power 3 by 2 plus c. So you'll get c as once again 1. So because 1 to the any power is 1 itself. So 3 minus 2, that's 1. So your f of x is basically 2x raised to 3 by 2 plus 1. That's the answer. Which if you wish to write like this, I can rewrite the same function as 2 square root x the whole cube plus 1. So that's the answer for this particular question. So here the function is given as that it passes through ln 4 comma 20, and it's been given that f dash x is 6e to the power 2x. Now just before we go ahead, there are certain properties which we must know for this problem. So for example, if you got e to the power ln x, e to the power ln x is nothing but x. And so any log like base, if you raise to the same log term, like a to the power log x to the base a, the answer is going to be x. So second thing is that if you're integrating e raised to ax plus b, integral of this is e to the power ax plus b divided by coefficient of x, which is a. Don't forget to do that. So f dash x has been given. So f of x is going to be 6 e to the power 2x over 2 and plus c. This e to the power 2x upon 2 we got because of this particular rule. So we get the function as 3 e to the power 2x plus 2. Now next part is to substitute x as ln 4. X is ln 4. Y is 20. So 20 equals to 3 e to the power 2 ln 4 plus 2, plus c, sorry, this is plus c here. So what we get is 20 equals to 3 e to the power, this you bring back 2 up in the power, so it'll become ln 16, because 4 square will become ln 16 plus c, and ln 16 e to the power ln 16 is 16 itself. So 20 equals to 3 times 16 plus c. So as a result, what we get is c is going to be 20 minus 48, which is negative 28. So your c value is negative 28. So your final expression for the function is 3 e to the power of 2x minus 28. This is the final answer. So here, first thing what we do is, like when you're finding out the area, it is important that suppose it's a given function. The given function is 6 minus or 2x over root of 16 plus 6x minus x squared. So we'll first find out what are the x and y intercepts. Even though I don't need y intercepts, plug x as y as 0. If I equate this to 0, I'll get x equals to 3, because this straight away multiplies to 0, and then 6 equals to 2x, you get x as 3. So this coordinate is basically 3, 0. Now second thing comes is, as you know that to get the area, you got to integrate the given function. So integrate 6 minus 2x over a root of 16 plus 6x minus x squared dx. So let u be 16 plus 6x minus x squared. So du by dx is going to be 16 derivative is 0. This is 6 minus 2x. So dx is going to be du upon 6 minus 2x. You put that out here. So you get 6 minus 2x upon root of u du upon 6 minus 2x. This get cancelled, and as a result we get du upon root u. If you integrate this, it's integral of u to the power negative half, which is nothing but u to the power half upon half plus c, which is going to be 2 root u plus c, and then you substitute back. Let's say u is 2 root 16 plus 6x minus x squared. Now the next step is to plug in x coordinate as 0, and second is x coordinate as 3 here. So if I take 2 root 16 plus 6x minus x squared as 0 and 3, I get the exact area. So if you plug x as 3 here, so you'll get 2 times root 16 plus 18 minus 9. So 18 minus 9 is 9. 9 plus 16 is root 25. Also, if I plug x as 0, with 2 root 16. So this is 2 times 5, which is 10, minus 2 times 4, that's 8. Hence, the resulting answer or resulting area is basically 2. So this answer that you get is 2 unit squared. So here what we have got is basically the function is f of x equals to x e to the power x squared minus 1. That's what you have to integrate. So this clearly is like evident that there is no straightforward formula that we have. So we've got to integrate this by using the substitution technique. So when you integrate this, x e to the power x squared minus 1 dx, let u equals to x squared minus 1. So du by dx that you get is 2x. So dx is nothing but du upon 2x. That you plug out here. So you'll get integral x e to the power u du over 2x. X and x cancels. So answer is half integral e raised to u du, half e to the power u, and then put plus c. So the integral of this is half e to the power x squared minus 1 plus c. Next one is when x is negative 1, y is 3. So you plug in x as negative 1 here. So y equals to 3. So you'll get 3 equals to half e to the power negative 1 square minus 1 plus c. This becomes 0. E to the power 0 is 1. So it's 3 equals to half plus c. So c is 3 minus half, which is 6 minus 1 upon 2, which is 5 upon 2. So your final function is half e to the power of x square minus 1 plus 5 upon 2. That's your answer for this given question. So here what we have is basically a similar question to the one which we just did. F dash x is given as 3x squared upon x cubed plus 1 to the power 5. Given that f of 0 is 1, find f of x. So you're going to integrate this. So f of x is going to be integration of 3x squared upon x cubed plus 1 whole to the power 5 dx. So let u equals to x squared plus 1. So du by dx is going to be 2x. So dx is du upon, sorry, this is x cubed here. So I'll take x cubed. So this is 3x squared here. So du upon 3x squared. So you plug in that out here. So it'll be 3x squared over u to the power 5 into du upon 3x squared. 3x squared cancel. So you get integral as du upon u to the power 5. Now after this you take it up. So it'll become u to the power negative 5 du, which is going to be u to the power negative 4 upon 4 plus c, which is negative 1 upon 4 u to the power 4 plus c. So if you resubstitute back, you get negative 1 upon 4 x cubed plus 1 to the power 4 plus c. You can just do one thing is plug in x as now 0 and y as 1. So plug x as 0 and y as 1. So you'll get the c value. So 1 equals to, this is y equals to, 1 equals to negative 1 by 4, 1 to the power 4 plus c. Because you plug x as 0, you're going to get this. And now you solve for c basically. So c is 1 plus 1/4, which is 5/4. So this is the exact constant for this expression.